Hi everyone, my name is Eral Bulut. I'm an electrical and electronics engineering student, and today I'm excited to share with you my Phys102 project. The primary objective of this project was to validate junction and loop rules by designing and analyzing an electrical circuit. The experiment involved measuring currents and voltage drops across specific resistors and comparing the experimental results to the corresponding theoretical predictions. Junction rule states that the total currents entering and exiting a junction are equal. It's based on the principle of charge conservation. Meanwhile, loop rule states that the sum of potential changes around any closed circuit loop is zero, based on energy conservation. For my experiment, I also used Ohm's law to calculate potential differences across resistors. I used a breadboard to design the circuit, which includes 6 resistors with varying resistance values, a power supply set to 10 volts, and a multimeter for taking measurements. After assembling the circuit, I measured the current by connecting them in series and the voltage values by connecting them in parallel. While the experimental results were generally consistent with theoretical predictions, there were notable differences. For example, current measures at specific junctions showed high error percentages, while some voltage measurements had minor deviations. Overall, the results still demonstrated the fundamental validity of Kirchhoff's laws. These discrepancies can be attributed to several experimental limitations: the precision of the multimeter, variations in the tolerance levels of the resistors, connection resistance on the breadboard, and possible human error during the measurements contributed to the observed error margins. These factors highlight the importance of accuracy in circuit assembly and experimental procedures. In conclusion, this project successfully validated Kirchhoff's junction and loop rules, demonstrating their relevance and applicability in the analysis of complex electrical circuits. Despite the experimental errors, the results reinforced the theoretical foundations of these laws. Furthermore, the project underscored the critical role of precision and attention to detail in minimizing errors and achieving reliable results in circuit design and analysis.